Assalamualaikum. So my group and I will present about quantification of caffeine in coffee using thin layer chromatography method. Chromatography is a method we use to separate mixtures. It works by passing the mixture through two phases. For the first one is stationary phase that stays still and a mobile phase that moves. So different parts of the mixture move at different speeds, which help us separate them. One real-life example is caffeine in coffee. It's important to measure caffeine for health labels and quality control. We can do this using thin layer chromatography or TLC, a quick and simple way to separate and estimate the caffeine in coffee samples.
Next, for the explanation, the first part is a part where a student analyze a beverage like coffee over multiple weeks. In the first part, which is step 1, they observe the drink packaging and content, noting details and forming question. And in the second part, student extract caffeine from the beverage and analyze it using methods like thin layer chromatography, which is it will separate the compound for caffeine. Next, we have caffeine extraction and analyzing. For caffeine extraction, first you need to prepare the beverage. If using soda, or you need to degas it, or if you're using coffee or tea, brew it normally. And for the part which is you want to extract the caffeine, they add sodium carbonate, which is help separate the caffeine to the drink in the flask. Pour into a separatory funnel, mix with dichloromethane, a solvent that pulls out caffeine, and drain the caffeine-rich solvent into a beaker. The third part is which is you need to isolate the caffeine. So you need to evaporate most of the solvent on a hot plate. Then let the rest dry. Then let it rest dry in a fume hood. Weigh the leftover caffeine, extract and store it for next week. Next part is analyzing the caffeine. First, you need to redissolve the extract. Add a little dichloromethane to the dried caffeine to make a liquid sample. Make it into 1 part for TLC. Okay. For TLC, you need to spot the caffeine sample and a non-caffeine standard on a TLC plate. Let the solvent rise up the plate, separating chemicals. And next, you need to use the UV light to see the spots and calculate RF values to see how far each chemical travel. Before you do this lab, there is hazards and precautions. Number 1 is hot plates. It can cause burns, and it must be used in a fume hood to safely evaporate solvents. Next is flammable and toxic solvent. Dichloromethane is a suspected carcinogen. Methanol ethyl acetate are handled only in the fume hood. The third is separatory funnel use. Student learns to gently swirl and release pressure to avoid spills or explosions. And the number 4 is glass pipette, prepared by instructor, not students, to prevent cuts or burns from glass or Bunsen burner. And number 5 is caffeine handling. It can be irritant. Gloves are worn when handling extracts. And number 6 is eye protection. Goggles are required at all times. And number 7 is waste disposal. All chemicals waste goes in the labeled containers in the fume hood for proper disposal. And for key rule, always work in the fume hood with flammable or toxic chemical, wear gloves and goggles, and follow instructor guidance. The objective of this lab is first, it teaches extraction technique, how to pull out a specific chemical, and the second objective is they show how separation methods or TLC done, and the third is it helps identify caffeine and possibly other ingredients in the drinks.
TLC result and discussion for caffeine. Caffeine extract is usually white but contain yellow if contaminated. TLC use basic lab items such as beaker, filter paper, and foil. TLC separated the compounds really well. We could get caffeine RF value between 0.5 to 0.55, vanillin RF value between 0.7 to 0.75. This shows TLC is effective and easy to use in school lab. The picture you can see in this slide was a result of TLC from caffeine.
For the conclusion, this lab experiment helps students learn how to extract and identify caffeine from drinks like soda, tea or coffee using safe and simple method. In the first section, students examine the component and packaging of the drink. In the second section, they separated and verified the presence of caffeine using thin layer chromatography, TLC, and liquid extraction. For product testing and health labeling, the experiment demonstrated how chromatography may be used to look for particular substance in combination. The TLC results verify the presence of caffeine RF equals to 0.50 to 0.55 and occasionally additional compounds such as vanillin RF equals to 0.70 to 0.75. Additionally, students mastered critical lab skills like handling chemicals safely, using fume hoods and hot plates, and properly disposing of waste. Overall, the experiment demonstrated the value of precision and safety in the lab while teaching practical chemical analysis procedures. We truly hope that this video has successfully explained and helped all of you gain a better understanding of the function and importance of thin layer chromatography, TLC. It has been a pleasure sharing this information with you. Thank you for your time and attention throughout the video. That's all from us for now. Until we meet again in the next presentation, take care and keep learning. Thank you guys.